Okay, so good afternoon, all of you. Can I start? Am I audible? Those who are online?
Yes, sir.
Okay. Uh, Last topic, we have discussion about the discussion was about the scattering diagrams. We found the calculation for coefficient of correlation. Yes or no? There we have some small terms. If you can see the book once, it will be better for you. So page number 356, because actually I'm not going to continue this topic now. So there are some small terms which only the formula is required to know. If you know the formula, you can directly get the answers. For example, page number 356. If you see this is Carl. You got it. So one of the topic is like Carl Pearson's probable error. So direct formula PE for probable error, and you can use the formula to get the answer. Similarly, there are some terms like rank correlation, which is called RK. So the formula should be known. Rest of the things are like which you already know, okay, to be put. So these things I'll be covering again in the last classes, like in the revision classes. So today I'm going to start module 7. Okay, I'm going to start module 7, and correlation regression coefficient is left. That one I'm doing as I told you before. So we are going to do probability. Okay, and if I give some idea, you will be getting these concepts easily. Okay, whichever 2-3 few terms are left, as I told you, the last class I will cover. Okay, so I am going to start probability. I think the math teacher has not started this. Math sir has not started probability. Not probability. Not probability. Okay. So probability. No, there is one. Is there probability in the maths topic also? No. No. Okay. So I am going to cover probability. Few terms are little difficult. Okay. So let's start. All right. So it is module 7 probability. It is module 7 probability. Okay. So you must have idea about probability. So I don't discuss much. I'll only discuss questions. Okay. So probability in general, we use this number of favorable outcomes. Okay, divided by the total number of possible outcomes. So using this, we go for finding probability. FAV is favorite in short. Okay, so number of favorable outcomes by total number of possible outcomes. So this is our main topic, and using this we'll try to find some of the probabilities. Anyway, question always comes from probability. Okay, uh, I write some questions and we'll also discuss. Okay, so supposing this is question number 1, find. Okay, a card is chosen. Card is means the playing cards. Okay, I hope you all know there are 52 playing cards. A card is chosen at random. A card is chosen at random from a deck of 52 cards, 52 playing cards. Now the question is, find the probability that that number A, it is a king, that it is a, find the probability that it is a, number A, suppose king, Number 2, suppose Jack of diamond. Number 3, suppose spades. Number 4, suppose the number 4, the number 4. Suppose number 5, queen of hearts. This one. Spades, S-P-A-D-E-S, S-P-A-D-E-S, spades. Okay. Queen of hearts, and suppose the last one, a black card. Okay. Now, so this is the question. We are going to find the probability for this. Okay. So this is all about actually the playing cards. See, I did not start very easy questions, which we can find easily the probability. Suppose I give an example. Okay, anyway, you write this. Done now? Very easy examples I have not taken is there. You can go through. I give an example actually. What is the probability? I'll explain this. You need to do this question properly. Though. Look at the board. Suppose there are 25 balls. It's a very easy concept. 25 balls. Out of these 25, suppose 10 are red. Okay, which you already know, I believe. 8 are white, and suppose 7 balls. 7 are suppose green. Okay, 7 are suppose green. Now the question comes in questions about probability. So suppose these 25 balls, they are kept in a box. These 25 balls are kept in a box together, and you have randomly chosen any one. You have randomly took out any one. The question comes, if one ball is taken at random, what is the probability of getting white ball? So how much chance is there of getting white ball? So when you put your hand there, your hand goes to white balls in how many cases? 8 balls. So 8 balls are white out of total. Okay, 25. Because the denominator is always the total one. Yes or no? So this is 8 out of 25. Now here if it is green, so 7 by 25, it is red, then 10 by 25. So here only I just tell you one thing. Supposing, that let me even complete it here only, because I believe it is known. Suppose the question is probability of getting white ball is 8 out of 25. The question comes, what is the probability of getting a ball which is not white? So probability of getting not white ball. So how many are not white? So 8 balls, 25 balls are there. 8 balls are white. Not white, what to do? 25 minus 18. So 17 balls are not white. So this is out of this. Getting it? 17 balls are not white. Getting it? So 17 balls are not white. Now these things can be generalized like this. Suppose now this number was 25 was there, so we could understand this number is, because 25 minus 8 is 17. But if it is not there, suppose the probability question is given like that. Probability of getting white ball, please try to understand, is probability of getting white ball is suppose 9 by 16. Getting it? Example. What is the probability of not white? Not white. So yes, we always subtract it from 1. The rule is, if probability of any event, if a probability of any event is suppose x, then probability of not e, we mark e dash or e bar, whichever. Okay, so probability of e dash, that means not e, it is just 1 minus p of 1 minus. So from 1 you have to subtract that. Actually, I hope this is known to you why 1, because the total probability of all the elementary events is always 1. So just you have to do 1 minus p of e is x. So 1. So using this now, since probability of white is getting white is 9 by 16, so probability of not white, what to do? 1 minus, and we get a required answer. Okay, so this 16 will be, LCM. So 16 minus 9 will be, so this is the probability. Getting it? Now, my question was, this is the basic things. Now, my first question is this one. So here, while doing this question, it's all about the playing cards. I hope you know what are playing cards and how many such cards. Do you know that? Okay. So total, I hope you know this division of playing cards. There are 52, because you see, to do this question or to do questions of probability, you should have a distribution of these 52 playing cards, which cards are there for how many times. So king is there, queen of hearts, diamonds, etc., etc. So to explain this, let me explain first of all the divisions. So there are total 52 playing cards that we always have. Now these 52 playing cards are divided into 4 categories. Do you know that? Okay, so 52, if you know this, it will be easy for you to understand. So these 52 playing cards are divided into 4 categories. The category names are spades, anybody? Hearts, diamonds and clubs. Is it okay? So these are 4 equal categories. Now they are equal categories. Any idea how many cards will each contain? 13. Because 13 fours are 52, so they will contain 13 cards. They will contain 13 cards. Now, out of these cards, the spades and clubs are all these 13 cards are black in color. So they are black. But these hearts and diamonds are red colors cards. That means if a question is there, what is the probability of getting a red card? So red card will be how many? 26 out of 50, or directly you can say half. Why? Because it will contain 2 parts out of 4 equal parts. Okay, so 26 it will be red card. Now these 13 cards have some special names. All these 13 cards have some special names. Okay, and these names are same for all. This is king, queen, jack. We also say joker. Okay, king, queen, jack. Then yes, ace card, ACE. So these are having names: king, queen, jack. I have the handwriting is okay. King, queen, jack, ace, and then the numbers: 10, 9, 8, 7, 6, 5, 4, 3, 2. There is no one card. So you count it 13 or not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You don't have to by heart anything, and by hearting you will not get answer also, because I am doing this, something else will come in the exam. So once this table is, these things is known to you, you can easily find all this. Now this is the division for spades. Same division is for the other two also. I am writing here for some reason. I am just repeating this line. So king, queen, jack, king, queen, jack, ace card, then 10, 9, 8, 7, 6, 5, 4, 3, 2. Same cards are here, but their colors and their symbols are different. Okay, king, queen. Okay, jack is also called joker sometimes. Ace, 10, 9, 8, 7, 6, 5, 4, 3, 2. Once again here, king, queen, jack, okay, ace, then 10, 9, 8, 7, 6, 5, 4, 3, 2. Now look at the board. They have different symbols. I will get to know. This looks like a diamond, yes or no? So this looks like this. So this probably it looks like something like this. Okay, I don't know exactly because I don't know all the cards. I know theory, not the practical. Okay. Anyway, so these are the cards. This there, no? Oh, and this one? Oh, is it like this? Like this, no? The correct, no? And this one is? Is it like this? I don't you know, don't take it as a correct, because I don't know actually. I know only this portion correct. As I told you, I know theory, not the practical. Okay, I don't know even playing cards. Okay, so this is done. Now here divisions are these only. King, queen, these all are same. Out of all these 13 cards, this king, queen, jack faces are drawn, so they are called face cards. They are called face cards. So they are called face cards. So once now this distribution is, you know, ready with you, you can do any question of cards. Actually, this is the reason why I am drawing this entire chart. Okay, because by hearting you will not get any answer. Now the question is, the first question is, try to answer how many face cards are there total. In each category three. How many categories? So total face cards are 12. Now question comes, what is the probability of getting a red face card? How many? Red face card. Red face card here, these are red, I show R, these are also red, so red face cards are okay. What is the probability of getting an S card, not given which color? So all colors you have to take. S card. So in every category 1 1. So 4. What is the probability of getting the number 5? 4 are there. Yes or no? What is the probability of getting a queen of diamond? In diamond there is only one queen. So if these things is ready, and out the total cards are always how many? 52. So your the denominator will be always 52. Now let's go ahead with the answers. And you know, we don't need any steps. Table is ready. Let's try to find the answers one by one here. So I just change the color. Okay. Please try to answer. Steps are not required. King. Say, what is the probability of getting a king? Not said any color and all. So it will be 4 out of 50, because there are 4 kings in each. 1 1 1 1 king. Yes or no? And of course, you will always convert to simplest form. It will be 1 by 13. A jack of diamond. Jack means the joker. In diamond category, sorry, just a minute. In diamond category, this is your diamond category. How many jacks are there? 1. So it will be 1 out of 52. Spades. The spades entire group. How many cards are there? 13. So 13 out of 52. Simplest form you can of course convert. So it will be like 1 by 4. Now the number 4, not said any color. So all the colors. How many 4s are there? How many 4 are there? 4. 1 2 3 4. So 4. So 4 out of 52. So it will be once again 1 by 13. Done now? Then the queen of hearts. In hearts category, how many queens? Yes, in hearts, this one. In hearts, how many queens are there? Only 1. So in hearts there is only 1 queen. So it will be 1 out of 52. And the last one, a black card. A black card will be means total black card possible is 26 out of 52. So it is simply 1 by 2. Done? Alright. So here in this, one thing you observe very carefully, and that is with this only I am going to start the next topic. This is said that a card is chosen. How many cards are taken at random? One card is taken at random. You close the door, AC is working. Close. A card is chosen at random. Now I am going to do similar question. 2 cards should be taken at random. Okay, this is now see what is this first question was, you know, a box was there, only 1 card is taken random. 1 card is just picked up from there. Now 2 cards, now 3 cards, now 4 cards we are going to do it. Together it is taken. And when more than 1 cards are taken, it is the concept of permutation and combination. I hope you have some idea about combination also. If not, I will give you a formula. We will derive this from the formulas. So now more than 1 card is taken. Okay, those questions are there in your books also. Now 1 card is taken, direct answer. So more than 1 card, like 2 cards are as a whole taken, 3 cards are taken, then how to get the probability? I am going to do this question now. Okay, done? Okay, right. Question number 2. So this is a direct one. Similar to this, you can do any question because these are all about taking one thing. Okay, a card is taken, a coin is taken, like that. Now suppose question number 2. Okay, suppose two cards are drawn. Two cards are drawn at random. Similar question, but two cards are taken out now. Two cards are drawn at random from same question, 52 playing cards. 52 playing cards. Okay. Find the probability that find the probability that number A, both the cards are queens. Okay, number B, the first card is a spade, and the second card is a diamond card. So like this we can have questions. We can have more. So let's try number C. One card is both the cards are black. Both the cards are black. Both the cards are black. Okay. Let's try to simplify these questions. Now, one thing you see, now 2 cards are taken, 3 cards are taken, 4 cards, process will be same. So I'm doing it 2 cards. You can extend it to more than 2 cards also. But process will be, as I told you, it will everything, the line by line will be same. Now see here, slightly difficult. Try to understand. There are 52 playing cards. There are 52 playing cards. Now, 52 playing cards, from 52 playing cards, you are taking any 2 cards. So from this, you are taking any 2 cards. Now, how many such possible, this time now it will come in terms of pair, because 2 cards are taken, or some different cards are taken, or so you are taking them as a pair, yes or no? So this is not a single probability, that means. So this probability will come in terms of pair, because you are taking 2 cards together. So, and without looking into the box, we are not looking into the box and trying to get the cards without looking. So we do not know which 2 cards are going to come in your hands, right? So in that case, how many such possible pairs can be taken out? That means in what different ways we can take all these two cards from. Of course, it will be more than 52. Yes or no? So when these 2 cards are taken, 3 cards are taken, total number of outcomes in the denominator. You know this denominator is always total number of outcomes. So this is what always goes in terms of combination and permutation. So combination is a kind of selection. Permutation is a kind of arrangement. Now selection to be taken. Why selection? Because we are not trying to arrange in different places. We are just taking out the cards. So it is this 52 cards are there. Okay, I'll give the formula if you do not know. So we are taking 2 cards from there. So it is 52C2, C for combination. We have a ready-made formula for this, and we'll put down values. Okay, so total how many ways 2 cards can be taken? I give an example if it is not very clear. So in this box, try to understand. There are 4 cards, A, B, C, D. There are 4 cards, A, B, C, and D. Please try to understand. 2 cards are you are trying to take. So when you are trying to take 2 cards, you can take A, B. You can also take A, C. Because you're trying to take any 2 cards. You can also take A, D. Don't say B, A also, because A, B and B, A are the same cards. So what else? You are taking A, B from there. You are taking A, C from there. A, D. You can also take the cards B, C or C, B, but they will be same cards only. So B, C. What else? You can also take B, D. You can also take C, D. Is there anything left? Is there anything left? No. So these are, so total how many ways? 1, 2, 3, 4, 5, 6 ways you can take it. Okay, you can take this in the 6th way. Now without doing this, now here the number of cards are less 4, so we got it directly. 52 cards, how will you do that? And you see how many ways possible? 1, 2, 3, 4, 5, 6. How many cards were there? So of course more than the numbers. So for this we have this formula. How many cards were there? 4. 4 cards. C for combination. How many cards we have taken out together? So this is 4C2. Getting it? This is 4C2. And formula I will give you. So instead of doing this, that means actually for bigger numbers it randomly taking, it's too long and too difficult. So that is why this 4C2 will give you the number. So it goes like that formula. So you can write this formula somewhere. It is NCR formula. NCR. If you do not know, write the formula. Factorial N divided by factorial R. This is called factorial notation. What is that? I am going to explain. Then N minus R factorial. Okay. Done now? This is the formula which we are going to use for 4C2. Okay. Now while doing this formula, you see now this 4 is the upper number. That means N. This C2 is the lower number 2. Now how to count it? See, the rule is N factorial. This symbol is called factorial. So N means the upper number. So 4 factorial by R factorial. R means the lower number. What? 2 factorial. Then N minus R. So what it will be? 4 minus 2, how much? 2 factorial. No? So I did directly 4 minus 2. Now, this factorial notation is, suppose I have 7 factorial. Look at the board. Suppose I have 7 factorial. You know what does it mean? It's very easy one. All the natural numbers you have to write in descending order. So from 7. So that means what? 7, 6, 5, 4, 3, 2. And then multiply. That is only factorial means. Okay, factorial is this. Now 4 factorial, what to do? 4 into 3 into 2 into 1. 2 factorial. 2 factorial means 2 into 1. Yes, you can directly say 2. This 2 factorial is also 2 into 1. Are you getting my point? So 2 and the remaining numbers in descending order. So now 2 ones are 2, 2 cancel, 1 cancel. Now 2 ones are 2, here 1, 2 cancel. So 2 3s are how much? This is 6. Yes or no? So as here I showed manually, here with formula, and manually we cannot do only because now 4 cards only we got total 6 arrangements. So we have here how many? We have here 52 cards. So 2 cards we are taking. So it will be 52C2. Which one? The denominator. Now I just extended. If it is 3 cards, now we are doing 2 cards. In exam came 3 cards. Same only. Then 52C, 4 cards. 52C. This is what? Okay. Now this is done for denominator. Now coming to the numerator. So denominator you have understood, I believe. So I am trying to do number A answer. So denominator is 52C2. Right? Numerator. Both the cards are queen. Both the cards are queen. How many cards are taken? 2 cards are taken. So out of these 2 cards, both the cards are queen. How many queen cards are there? How many queen cards? 4. So try to understand. You know, queen cards there are only 4. So now, although there are 52 cards, these 2 cards will be coming as queen. So go for the first card. How many queen cards are there? 4. Out of 4, any one you have to take only. Could you understand my point? 4 queen cards, 1 card should come in your selection. Done now? Now, there were 4 cards, already 1 card gone here. Now, let us go for the next card. How many queen cards are now left? No, there were 4. Already have taken 1 now. This one is taken from there. How many cards are left? 3 left. So, out of from those 3 remaining, again 1 queen cards to be taken. And then, these 2 you need to multiply. This is the actually multiplication principle of, probability. So, denominator is easy, numerator is confusing. I repeat this numerator once again. Both the cards are queen. How many queen cards are there? 4. So, there are 2 options, first card, second card. Now, from those 4 cards, the first card, that means 1 card to be taken as queen. So, you have taken. Now, since there were 4 cards and 1 card already taken, so 1 card already gone. Now, how many cards remain? 3. So, out of those remaining 3, again you need to take 1 queen. Could you understand my point? And then their product you need to do it. And I won't go for finding, I just explain once again because you are doing it for the first time. And 4C1, can you say that? 4C1, any idea, anybody? There is a direct formula also. NC1 is N. 4C, so 4C, this formula, you can check it. NC1 is N. So actually, why it is 4, then 4 minus 1 will be how much? 3, 3, 2, 1, 3, 2, 1 will get cancelled. So directly let us write NC1 is N, so 4C1 is 4. 3C1 is 3. And this one you have to find out how? 52 factorial by, say, what is the formula? 52 factorial, you see, this one, n factorial, then r factorial, n minus r factorial. So n means this first number. So here, yes, 52 factorial down r factorial, which is r? 2 factorial, multiplied by 52 minus 2, how much? 50 factorial. Okay, I'm showing the calculation for this. Done now? Is it okay? Now, this 4 3s are 12, we don't have any problem in that. Yes or no? Now coming to the denominator. As I told you, 52 factorial means 52, 51, 50, 49. So it will take time. What you will do, we will stop at 50. So actually it's like that. 52 factorial means 52 into 51 into 50, 49, etc., etc. This is simply equal to which number? 50 factorial. This is simply equal to 50 factorial, because from 50 and below, whichever numbers will be coming, they all are in 50 factorial. Why this is actually done? Because this 50 factorial from the denominator will be able to cancel. So these will get cancelled, and 2 factorial, as you know, 2 into 1. Any doubt? Any doubt? Now this is 51, 51. Now again this 1 no use. By 2 you can cancel this. How much? Sorry, 20, 26. Now what is left? 12 by whatever, 26 into 51, 3. This is the answer. This is the probability. Getting it? Now, try the second one. I hope this point should be clear. Remaining things are only calculation. Okay. Now let's try the second number. The first card is a spade and the second card is a diamond. There are 2 cards taken. First card is a spade. Can I erase it? The first card is a spade. Second card is a, denominator is same, so we have no problem on that. Let's go to number B answer. So these questions are very common in exams, your exams. Okay. Done. Now, coming to number B. B answer. Coming to number B answer. Okay. So let's try B. So denominator is same only. How many cards are taken? 52. C, 2 cards are taken. Now try to answer. There are 2 cards. 2 cards. Okay. First card is a spade. How many spade cards are there? Huh? 13. So from 13, this is spades. So from 13, how many cards are taken? 1. Then again, the second card is a diamond. How many diamond cards are there? Again from the 13 cards of diamond, 1 card is to be taken. Now see, the last time it decreased because they were the same queen cards or whatever. Yes or no? But now you see spades cards 13, so 13 is taken. Had this question be both the cards are spade, so then 13 C1, 12 C1. Then one, because this one card will go there. But now this is different, this is different. Suppose this student is taken from boys, that student is taken from girls. So boys numbers will not get decreased. Yes or no? So this 13 C1. Why 13? Because spade cards are 13 and we are taking the first card from spade. Again diamond cards are also 13. From here we are taking 1 card, is the answer. Okay? Done now? And again for calculation, 13 C1, how much? NC, this is the formula. NC1 is N. So 13 C1 is 13. Again 13 C1 is, and 52 C2 I found once again. I'm showing that so that later you will not have doubt. 52 C2 will be 52 factorial. Say next. 2 factorial. This number we take alone. And then 52 minus 2. How much? 50 factorial. What is 50? 52 minus 2. Okay, so 13 as you know 169. Done. Now 52 factorial I showed you how to factorize or how to find it. So you have to do 52 into 51, then no need 50 factorial. Yes or no? 2 factorial as you know already 2. 50 factorial will be 50 factorial. So they get cancelled. By these 2 you cancel, it will be 26. Okay, so once again 169 by how much? 1 3 2 6. Try the last one. Both the cards are black. Done. Both the cards are black. That means black cards are there. 26. Okay. Denominators. This is number C answer, huh? All of you. So denominator will be same only. 52 C2. Now black cards. You know there are 26 black cards. Sorry. 20. The first card we are taking. So 26 C1 multiplied by, yes, 25 C1. Why? Why 25? Because out of those 26, one card is already taken. So only 1 card is left. Okay, the calculation you can do it anyway. All right. So I'm writing a question from this question. You'll try. One part is common in your was the previous from previous year paper. Can I go to the next? Okay. Right. Question number 3. Is it okay, everyone? Those who are online, is it fine?
Yes, sir.
Okay. Let's start. Question number 3. A committee of, right? A committee a committee of two persons. A committee of 2 persons is selected from 2 men and 2 women. It is a question from last year's one of the paper. Okay, find the probability that the committee Find the probability that the committee will have number A, no man, number B, one man, number C, one man and one woman. Okay. Now, first you tell me, is it a question of this combination concept, or is it the previous one? See, this number was direct, we did not use combination. I showed you why and how it should be used. This question is a question of combination concept or direct? Direct? Say yes or no. Problem is here, otherwise question is easy. That means, should I do like that? No man. No man means both all are in the. See, a question you want us to know? A committee is to be made. Suppose one chairperson, one vice chairperson. So they are the members or the portfolios. They will have like a chairperson and vice chairperson. Okay. Now these two persons will be representing the committee. Only two persons. But that is to be selected for. That is to be selected for 2 men and 2 women. Okay. Now the question is, that means that there were 4 people as a whole. 2 men and 2 women were sitting. Only 2 persons were taken. Now question is, what is the probability that the committee will have no men? That means, no men means what? Both will be? So how many women? Out of? Is it the answer or not? What I was highlighting last, this is not, of course, not the answer. This is, of course, not the answer. What I was repeatedly saying is, even I underline this one. One if taken, then fine. A card was taken, so no combination and all. Now more than one thing when taken, then we should go 2 cards, 3 cards. So this question, last question was for 2 cards. Yes or no? 2 cards. I told you, if 3 cards, then you take 52C3. Yes or no? So more than one if considered, then you should always go by combination. Because, see, the committee has how many people? I just draw it to make you understand. Then I'll go for, okay. So, who all are there? 2 men and 2 women. Yes or no? Now, how many people to be taken? And both the men are not same anyway. So, men 1, men 2. Yes or no? Women 1, women 2. Okay. Now, from here, men 1, men 2 both can be there. Man 1, woman 1 can be there. First man, last woman. So these are the possible things in the committee. Yes or no? So that means we are taking any 2 from there, and that means it is a situation of combination. Okay. So now how easily we understand? More than 1 people are taken. You see, a committee has 2 persons. More than 1 people are taken. So it is a question of combination. Okay. Can you try? First one. How many people? I just give you one example. The first one. How many people to be taken and from where? Total how many members to be taken? Total 4 people are there. How many to be taken? How to write it? Yes, 4C2. This is 4 people, then 2 people are taken out of those 4. Say, no man. No man means both are what? See, only 2 people are selected. Only 2 people are selected. There will be no man. That means both will be. So from where to take these women? How many women are there? 2. So 2 women. From those 2 women, 2C?
2C2.
Yes, both the women to be taken. This is the first answer. Okay? This is the first answer. So you find it, there is a reason why I am asking you to find. 4C2 will be 4 factorial, keep saying 4 factorial by. 4 factorial by. R factorial, no? Do you remember the formula? NCR. NCR formula is n factorial by r factorial, then n minus r factorial. This is the formula, n minus r. n minus r factorial. So this is the formula. Now actually there is a reason why I am asking you to do it. So now set a denominator r factorial. How much? 2 factorial. 4 minus 2, 2 factorial. Numerator. What is that? N factorial. N how much? 2 factorial by r factorial. How much? Try to understand. Into. We do know n minus r. So n minus r, 2 minus 2 how much? So don't think this 0 factorial. Actually 0 means 0. When 2 factorial 2 into 1, 0 factorial is actually, it is not a term that can be found using this. 0 factorial is considered as 1. So 0 factorial is considered as 1. So this is considered as 1. It cannot be verified. Now, so this is 1, right? 2 factorial by 2 factorial how much? 2 factorial by 2 factorial? They'll cancel or not? What is the answer then? So you can directly write this. Look at the board. NCN. Whenever same number comes, NCN is direct. Like last time I said NC1 is n. Now when NCN it is, so 2C2 same number in both, so 1. And this one now easily you can find out. Okay. Try number B answer. So these are the formulas that you can use. Now try the answer of B. Easy only. Denominator I can write anyway. 4 people are there, 2 people to be taken. 1 man. That means the other one is a O man. How to do it? 2C1. Because there are 2 people, 2 men, 1 man is taken. If 1 man is taken, how to fill up the other place? Because the committee will have 2 people now. So if 1 man is taken, how to fill up the other place? The woman must be taken. So how many women are there? 2. So from these 2, okay. And NC1 is how much? 2C1 is 2. Yes or no? Okay. So you can complete, I believe. Third one is it actually the same answer? Third number C is the same answer or not? So if 1 woman, the other one must be. So this C answer and B answer are same, although they look different. Yes or no? Because if 1 man is taken, other one must be an woman only. Okay. So write few notes which we'll discuss in the next class. Is it over, all of you? Okay. Right. Multiplication principle of probability. Multiplication principle of probability. For any 2 independent events. For any 2 independent events, probability of A and B, which can also be written as intersection. I hope you have some idea about this symbol. It is both. Yes or no? It is equal to P of A multiplied by P of B. Actually, we have used just now this one. Okay. Now our questions will be of Bayes' theorem. Okay, Bayes' theorem. This is more important. Okay, Bayes' theorem. an event A occurs if and only if and only if and only if mutually exclusive and exhaustive events EN occurs. Okay. So this is called Bayes' theorem. So this is the last one for today. That is the theorem. We will continue tomorrow. And tomorrow this what is that? Probability will be over. Your main important topic actually is Bayes' theorem. Okay, it is all about conditional probability. And then for the last, last module, I need only one class, but one more class will be required to revise the things which is not being done. So in 2-3 classes, statistics portions will be almost over. Okay, so you write this now. I'll discuss it tomorrow. Okay, I just give the formula. Okay, okay then. Thank you.
Thank you.